Okay, so all the homework assignments added together will be 20%. This first exam itself is 20% of your entire grade. Now, whether people should drop or not is a really hard question to answer because someone who did nothing can still pass the class if that person aced in the last final exam. So that gives you some idea of, at least it gives you an idea of the percentages. Okay, if someone completely, got wiped out in the first exam, let's say it was a flat 0. Okay, it's really hard to get a flat 0 in this class because of the open-ended questions and partial credit. So that means if you get like the first 2 lines done, in a trace, you will get some points already. It's really hard. Someone has to work really hard to get a 0 and still submit something, right? Assuming the homework is mostly okay, and the second exam is okay, and the final exam is okay, taking out the first exam altogether means that you will only have up to 8% in the end. So that will basically get you out of, an A will no longer be possible because an A is 87.5% or more. But a B is still well within your reach. Okay, I'm not saying you, but that person, who got 0.
This imaginary person, yeah.
Yes. Yeah. So any person who gets a flat 0 in one single test, the first one, can still potentially get a B out of the class, because a B is 62.5% or more. So a B is still well within reach of that person. Right. Okay. Any other questions? Yep. Oh, okay. Because you point to it, I thought you were about to ask a question. No other questions? Okay. Does anyone want to know why I do not ask really, really easy questions? I just don't want to waste my time or your time to ask and answer questions that everybody can do, like to fill up that first 60% of a normal class. It is not interesting. It is not contrasting, right? Assessment. I do not really intend assessment to be a prism. Do you know what a prism does? From your physics class, white light goes in and what comes out? It spreads out, right? Okay. So I do not really intend my test so that I will basically be able to tell the worst student from the best students, and the difference will be this big. If the entire class performs well, I have no problem with the entire class getting A's. If the entire class do not do well and nobody seems to understand the concepts, they can all get lower grades. But then I would be asking myself, did I teach the concepts correctly in the class? Because that may be an indication that the problem is not with the students, but with my way of teaching the class. So I would actually look at the result of an exam, and basically reassess, how the class is going. Am I going too fast, going too slow? Why are people making mistakes like this or that one? But it all depends on the distribution of the class. Like if 75% of the class gets one question right and only 1/4 of the class got it wrong in a very minor way, I would just say, well, people do make mistakes sometimes, and it's not a big deal. So, are there any questions about the first exam? No questions? Okay. So what we'll do is to continue with our notes from last week. And of course I have no idea what I talked about, or the last topic that I talked about last week. So I'm going to rely on my own recording to remind myself. Sorry?
We talked about
Loop invariance, okay. Very good. So let's go to the last few minutes of last time. That doesn't look like, I think that's an example, right? That's an example.
Yeah, last class we just went over examples.
Yep. Okay, so are we done discussing the whole concept of loop invariance?
Yeah,
We're done with that. Have we? Sorry, I couldn't catch it. Right, exactly. You don't have to think about it too much. They will not be in any exam. So the final exam will not have loop invariance. It will still have pre and post conditions in general, kind of like what we have in this class, in this particular exam. But loop invariance will not be a part of it because it's just kind of well beyond the scope of this class. Okay? So let's go ahead and start on a new topic. Hopefully that... Have we gotten started with top-down design yet? No. Not with this class? Okay, so let's go ahead and get started with that one, unless there are additional questions about the stuff that we have currently covered. Okay, so let's go ahead and deal with top-down design, which is a very important topic. The important part of top-down design is not, what it is. It is why it is necessary. Okay? And at some point, why it is necessary is actually going to be pretty easy to understand. To illustrate why top-down design is important, we go to Google Maps. There are many ways to illustrate top-down design, but this is one quick and easy way because we all know about maps. In the good old days, we don't use GPSs. Okay, back about 20, 30 years ago, I'm sure the military already had GPS or similar technology, but civilians, do not have anything quite like that. So whenever you have to go to a place where you have never been before, it's on a street that you have never been before, even the whole neighborhood, the whole region is new to you, what do?
Go get a map.
You go get a map, okay? And AAA is good, okay? The AAA, California AAA Automotive Association of America, I think. Yeah, they're really good with maps, because once you are a member, at least in the past, you can get free maps. Do they still give free maps?
They do.
Okay, but you can also be a non-member and buy the maps, through a vendor machine.
Right.
Yeah, that's pretty smart. They can make some additional money that way.
And they're good maps.
They're good maps, but being good maps, is it easy to find something if they don't have an index? So forget about the index on the map. Yeah, because if you don't have an index, what happens?
You don't know where to start looking.
Exactly, because how many streets do you think are on one single physical map?
Dozens. Dozens.
Dozens? Yeah.
Depending on the map.
There may be dozens in one of those little squares. Okay, even if they tell you that a street is in a particular square, I would still have to spend at least a few seconds to scan that little square to locate that one single street. Okay, so when you talk about the entire map, it probably has hundreds of streets, if not more. Okay, so what is the problem of locating one single street within hundreds of streets?
You have to know where to go.
It takes time, right? Your eyes can only scan so fast, over the map. Even if you do it in a very systematic way, like sweeping, it will still take a lot of time to pick out one street out of hundreds of streets. Now, when you think about, okay, let's generalize it. Okay, so in this case, even if this map, even if the projector is capable, have the resolution to display a lot more than what is currently displayed, the limitation is no longer the projector. The limitation is how quickly can you scan a map and locate one item out of potentially 50, 60, 100, a few hundreds. That's the question. Does anyone know how many things the human mind can track at any particular time?
6.
I would say 6 to 10 is probably a reasonable number. One student from one of my other classes, one of my other cisp300 classes, he said that he knows someone in the military as an air traffic controller, and that person can keep track of 50 to 100 aircrafts on the radar at at any time. That's pretty amazing. Okay, but I would say that is probably about 2 standard deviations from the norm. Most people cannot do that. You give me a phone number, by the time I get to the last digit, I would have forgotten the first 3. Okay, I'm pretty sure that's not, the usual case. So I'm on the other, I'm still 2 standard deviations on the other side of the norm. Okay, but that's why we need top-down design. Okay, that's why it's because the human mind can only keep track of so many things at the same time. Now, on the other hand, you can look at it from a very practical perspective. Okay, here's a dumb terminal. Let me just turn it out, give it a clean tab. Okay, you don't have to read the text here. There's no need to read the text, but this is pretty much showing you the smallest font that I can deal with as a programmer, and I can read pretty small fonts already. How many lines can I fit on one single page, even using this font here? Now, I know I'm not using the maximum resolution of the screen or the projector, but let's do some calculations. What is the highest resolution monitor? What is the number of pixels vertically speaking?
80, 20, 48.
1200? Okay, let's say 1200, okay, just to make it round and easy to calculate, okay? It's about that region, okay? How many pixels do you need per line for programming purposes? So we're not talking about word processing or page layout, that sort of thing. Just for programming, you just need to be able to tell A to Z, and all the digits and all the punctuations and whatnot. Let's say 8 pixels. Okay, 8 pixels is not a bad assumption because back in the good old days with the LCD displays, most of the time each character is displayed as 5 wide by 8 tall. Okay, and with that, it's really really not so good already, but you can still differentiate all the letters and all the digits and all the punctuations. How many is that? I mean, it gives you 150, right? So when you really push it, I would call this really pushing it, you can display up to 150 lines of code per physical page on the screen. Okay? Now, what if you have a subroutine that has 500 lines? It does not fit on one page anymore, does it? What is the problem when you have a single algorithm that spans over, say, 3 pages of 150 lines? You cannot really see the beginning or the end of constructs anymore, okay? Because you're basically looking at a huge, long algorithm like this. But at any particular time, your screen is a window that can only display this much. In other words, if you have a construct that starts here and it ends here, you can only see either the beginning or the end or just the middle part of that construct at any particular time. What is bad about this?
It's hard to trace.
It's really hard to trace, exactly. If this is a conditional statement and you're right in the middle of this part here, you would not have any idea of I'm actually inside a conditional statement. And if this conditional statement is inside a loop, and this loop is inside another conditional statement, you can see how quickly people can get lost when they can only see this part or this much of an algorithm, and the algorithm is much bigger, or the constructs are much bigger than what you can see on the screen. That puts another limitation on why we need top-down design, because of the number of lines you can display on the screen at any particular time. 150 is really pushing it because it takes up the entire length or height of a screen already. Most of the time you don't want to do that because you have other files to open when you are actually programming. I am not a particularly good programmer, but I do my fair share of coding even today. I still write code. I would typically open up 6 or 7 terminals in order to write programs. It's because a lot of times when you are writing one program, you need to refer to other subroutines, and you also need to refer to the data structure definitions. We'll deal with that later. But you need to open up multiple windows, which means you can't really just use one single window like this and take up all the real estate in terms of the vertical dimension. So that means realistically speaking, as far as I'm concerned,